How's it going, everyone? Welcome, Euler Gonzalez here. So, let's take a look now at the chapter 5 and chapter 6 in today's video, at least to make a sense of not only what is a scope in JavaScript, but also is another important topic, which is how to work with variables and how specific declarations behave when you now, for example, define them pass appear or you define them appear past the first declaration or the first statement. So what happens, how now any reference before that declarations will be resolved, and what happened when we have now variables with the same name as well. So this is part of the story. So scope is part of the story when it comes to understanding how your programs work. And the other is now the variable declaration, or this specific syntax that now behave exclusively in JavaScript in this way. So because in this chapter 5 we look at not only working with scope is quite important in order to understand what the scope is, why we have a scope as a way to have a common place where several modules or variables that can held inside of that values, not only primitive, that allows to represent its particular state of our application, like a string or a number or a boolean or any kind of emptiness, null or undefined, or as well as a symbol to private values, but also to objects, right? And how this object is describing is now a particular state in functions, which describes now a set of instructions that is going to be executed when you need it, aka when you call it. So because of this nature of the language, especially for any language that make functions as first class citizens, aka that you can held inside of a variables. So since this scope in which these variables and blocks and functions interact with each other are defined by the scope rule, and this is something that happens before the code is executed, at least in JavaScript, despite that this has been a scripting language. But the way it, and I am not made this up, is something that we can observe is based on how now the errors is evaluated in the language. So for example, syntax errors, early errors, and hoisting. All right. So hoisting, which is a particular concept that is useful or is important for us to understand, at least in JavaScript, right? Something that only happens in other programming language like PHP, for example. They have for only for functions they host that's declarations, but this is not true for other programming languages, right? But the point is that this particular features known as hosting that it allows us to is certain declarations, variables and functions, as well as let and cons are hosted. I put it at the top of the scope, and this scope is determined based on the function declaration, specific functions declarations. So for example, functions, block, and also the catch inside of the try catch, Okay, uh, this is something that when you call this or when you execute this function or block, uh, a new environment record is created, which whole is the identifiers, the names, with the variables of the or the functions. So I mentioned this because we can also take a look at the ECMAScript that describe that. But I mentioned this because most of the time we're quite familiar of functions, declarations, and that it create now a particular scope. It also is function expressions. But function expression, unlike functions declaration, they cannot be hosted. All right. Uh, in another scope, which is the block. And how now, for example, when you're working with scope, how now, because this is a source of a confusion, I had that. How variables with the same name in different nested scopes are resolved? And what happened when you have now variables with the same name at different nesting scope? And this is known as shadowing. All right. So shadowing is something that occurs lexically. You can of course create an OPI and try to access to that, but this is not before the code is executed. So it's not accessible during the parsing phase. So this or this particularly feature of variables with the same name at different nested scope, known as shadowing, and also is that how is that possible that variables, the names or identifiers, different scope know which one of those variables it can have access to, and this is determined via the outer env property, aka each one of those scope, whether it's block or function or the catch in the try and catch, each one of them has a reference to the outer scope, and so on and so forth until it reach to the global scope. There are also other type of scope, which is implicit scope. For example, parameter scope in your functions. That's something that's mind-blowing. In other words, you shouldn't do that. don't overcomplicate your life in there. And also is the difference between function name and function parameters, or function names, function name declarations, and an arrow function, and why this is useful, especially function names, because you can now lexically point to that, unlike anonymous functions, and this function names serve as a descriptor or what it does. So you don't have to spend time to understand what this algorithm is doing. So the name is pretty self-descriptive, which is also part of the functional programming. So this huge overview of a scope, right? As well as in some other metaphors that I'm not going to mention that, because I think those metaphors they serve as a good mental models, but this mental model must be aligned to what it is, right? And you can make use of them. It can help you with certain understanding of what things or how the things actually works. But at the end of the day, it's better to understand now deeply how the things actually work based on the observable behavior. Now, having said that, it is now turn to explore is what this scope is, especially the global scope. And because here is a place where we can now is share and collaborate among different variables that they can hail functions, and these functions can describe as now certain features or models inside of those functions, right? It is useful for us to now say, all right, um, okay, so it is useful for us, right, to say this. Hey, do we want this? It's useful to us to understand what what the global scope mean. That serve as this place where we can now share and make and collaborate across different files, standalone files, or different models. And the way we traditionally do that, at least in the browser, is well, by defining is this ES models. All right, when you use the import keyword, they're going to now link or fetch that JavaScript files and process that, and so parse and execute that. And if that particular file contains more import, it's gonna do that, so on and so forth. This might not go. This is something that might not be great because it requires to now. It involves in several cascading HTTP requests. So yeah, you don't want that, especially if your application is huge. There are other techniques that allow to collaborate with in a much more straightforward fashion. That is, well, let's going to now bundle up all of the JavaScript code, all right, and then now serve this content to the engine, the browser. So now on the browser we can via the UMD, which you can think of this like a function scope or enclosing its functionality, usually in a function that is in there. Defining is all of these models. So this is variable one, aka the model one, that has all of this set of instructions, so all of this set of features and data. The model 2, this, and then you can now in this particular enclosing scope cooperate among them, right? And the last but not least is the global scope, which is, hey, let's go to now append all of these standalone files, or aka these functions, attach that into a variable at the global scope, and then make then access to that. So for example, React is well known at doing this, jQuery as well, Google Analytics is another one. So one of the trade-off of this is that so all of the questions here of the scope, and especially why it's not great to use the global scope or to pollute the global scope, is because there are several things. So one of them is, hey, the name collision. So if you now for some reason has variable with the same name, they will override the previous behaviors. So not only that, but also is that it is quite hard to maintain in and also for privacy reasons. If you expose these objects to the world, if you expose this variable to the world, there are some internal features that you don't want to expose that. So for example, if you have now the Google tag, and if this Google tag now whole is this entire, how do you call it? Yeah, this Google tag now hold this entire data, and you have now some private data, for example, like client ID, the API keys, so on and so forth. You definitely don't want to expose that, but perhaps you need to use that internally. So because of this, right? This is why using now an enclosing scope, aka not relying on the global scope, is something that, well, is well adopted right now. But the point of this is, I just want to mention is the different global scopes according to the JavaScript environments. So first, you have the global scope in the JavaScript engine, where you can say, hey, this global you can access through via window objects. When you define variables, it's going to be attached to the global variable. Whether it's variable declaration or function declarations, let doesn't do that, or cons not as well. And also you can now select is element in the DOM via its ID. And you can also do some global shadowing here. Another environment is the worker, where here you're going to access to the self. This runtime doesn't have access to the DOM, but it can have access to other related APIs. So for example, is the navigator. Here also, if you define now the variables and function declaration, you're going to be attached to the global self environment. The other is the ES6. So you can think of ES6 as now a enclosing scope, aka like a function that is going to export your function. You're going to have access to that via exporting that. So here in the ES6, we don't have any global top model, okay? So all of your variables declaration and definition will be now part of the enclosing scope. The other is the developer tools. In now how the developer tools works quite different in terms of it is hosting. Okay, again, something we're gonna see that in today's video. In the node environment, so every time that you now load a JavaScript file in node, it will act as a single model, aka you don't have access to, especially if you work with CommonJS, you don't have access to a global definition as it is, right? So because of that, right? Yes. So because of that, the thing here is, we so far look at the here in Node, we have now access to the global environment, which is something that is recently added, the global disk. So in each one of those files that you load in Node, you can now have access to this global environment. So this is just to recap about the global disk and the global scope, and especially then how now variables behave according to it is declarations. So we look at var, we look at the declaration, we look at var function declarations, how they behave according to certain scope. So for example, global scope or function scope, where now hosting happens, and what happens when you now have variables with the same name at different nested scope, what's going on there, and also is that how those variables are hosted. What is the variable that are being hosted? Okay, so it turns out that the variables with the same identifiers, it will, if one of those declarations is a function, you're going to prefer the function value and put that at the top of the scope. So here is when we look at the difference between function declarations, function expressions, how now, for example, is variable behave with scope, with block scope, with function scope, also how the variable and let behave, and how now let, and how now hosting also happens in let and cons in the block model based on its observable behavior that is now hosting all of those variables, all of those identifiers, but only when you now declare that you can have access to. And this time and space based on the declaration of your functions, based on the declaration of your variables, let and cons, and the moments or the moment that happens before that declaration, this is known as a temporal dead sum. Variables and functions have this temporal dead sum, but they are not observable. It is not perceivable for developers. And also we look at how now, for example, var, let, and cons behave when we iterate the code, or for iteration syntax. So while, do, for in, for of, and especially with cons, with for, okay? And it turns out that only with cons when there is a specific trade-off. So all of this, all right, is just to now have a crystal clear understanding of what's happening with the variables, definitions, var, function, let, and cons across different scope, functions, and block scope, as well as how they behave with syntax loops. And I do think that is quite revealing, right? And I do think that is quite revealing, especially the let and the cons. Why let and cons auto initialize and they don't now have any values? So for cons, it makes a lot of sense, because if you initialize a constant with a value and then you reassign with another value, so that's not how constant works. But in the case of let, it say, hey, well, they're just going to follow the cons behavior, right? So in any case, so finally initialize. Working with variable has much more nuance than it seems at first glance. Hoisting, redeclaration, and TDC are common sources of confusion for developer, especially those who have worked in other language before coming to JS. So before moving on, make sure your mental model is fully grounded on this aspect on JavaScript scope and variables. Hoisting is generally cited as an explicit mechanism of the JavaScript engine. but it's really more a metaphor. Exactly. So hosted is generally cited as an explicit mechanism in JavaScript, but it's really more a metaphor to describe the various ways JavaScript handles variables declarations during compilation. But even as a metaphor, hosting offers useful structure for thinking about the life cycle of our variables or any hostable declaration when it is created, when it is available to use, and when it goes away. So what happened when it's created? Var function let cons when it is available and when it goes away. Redeclaration and redeclaration of variables tend to cause confusion when thought of a runtime operation. Exactly. But if you shift to compile time, thinking for this operation, the quirk and shadow diminish. So it actually makes more sense and it behaves the way it works. The temporal dead zone error is strange and frustrating when encountered. Fortunately, TDC is relatively straightforward to avoid if you're always careful to place let encons. As you successfully navigate these twists and turns of variable scope, the next chapter will lay out the factors that guide our decisions to place our declarations in various scope, especially nested blocks. Here we are. Limiting the scope exposures. So far has been explaining the mechanism of how scopes and variables work. With that foundation now firmly in place, how now scope and variables works, our attentions rise to a higher level of thinking, decisions, and patterns we apply across the whole program. Today we're going to look at how and why we should be useful, how and why we should be using different level of scope, functions, and blocks to organize our program's variables, especially to reduce scope overexposure. So let's go to reduce the scope overexposure, the least exposure. So it makes sense that functions define their own scope, but why do we need blocks to create scope as well? Software engineering articulates a fundamental discipline typically applied to software security called the principle of least privilege. So a variation of this principle that applies to our current discussion is typically labeled as least exposure. Principle of least exposure. Principle of least exposure express a defensive posture to software architecture. Component of the system should be designed to function with least privilege, least access, and least exposure. If each piece is connected with minimum necessary capabilities, the overall system is strong. Okay. If each piece is connected with minimal necessary capabilities, the overall system is stronger from a security standpoint because a compromise or failure of one piece has minimal impact on the rest system. Okay. So the only joint, so if each piece is connected with minimum necessary capabilities, the overall system is strong from a security standpoint because a compromise or failure of one piece has minimized impact on the rest of the system. If POLP focuses on system level component design, if principle of least privilege focuses on system level component design, the principle of least exposure variant focus on a lower level and will apply it how scope interact with each other. In the following poll, principle of least exposure, what do we want to minimize the exposure of? Simply the variables registered in each scope, which is exactly why I was explaining this a little bit, alright? And especially on the scope, which is the central place and where we can now interact. Okay. Yeah, it's a central place where we can now interact. Yep. So to make now all of the different models to cooperate amongst them, uh, but for security standpoint, if some model is compromised, it doesn't compromise the entire overall system. So naming collision, if you use a common and useful variable function name in two function part of the program, but the identifier comes from one shared scope, like the global scope, then name collisions occur. But all of this, the principle of least exposure, is following is a paradigm, I will say, or is is a discipline or is an approach to security, which is the principle of least privilege. All right. But in the case of this, uh, low-level programs, not as the system-wide component design, but more like a variant at a low level, the principle of least privilege wants to minimize exposure of variables registered in each scope. And think of it this way: why shouldn't you just place all the variables in your program in the global scope? That probably is immediately feels like a bad idea, but it's worth noting why is that. First is the name collision. So if for some reasons now variables with the same name in your programs, with the variables or functions naming two different parts of the program has the same identifier, okay, in the same scope, the name collisions occur. Not only it means that it's going to override its behavior. So it is something that you don't want to do that. For example, imagine if all of your loop use a single global index variable, and then if it happens that one loop in a function is running during an iteration of a loop from another function, and now they share the I variables and gets an unexpected value. The other is unexpected behavior. If you expose variable functions whose usage is otherwise private to a piece of programs, it allows the developer to use them in ways you didn't intend. So for example, if your part of your program assumes an array contains all numbers, but someone else code access and modify the array to include booleans and string, your code may be misbehaving in unexpected ways. Worse, exposure of private details invite those with ill intent to try to work around limitations you have imposed, to do things with your part of the software that shouldn't be allowed. So this unexpected behavior is that by exposing variables or functions that are private in your programs, you might expect unexpected behaviors. Okay, so developers can now using with okay, so developers may use this with unintended consequences or unexpected ways. And the other is unintended dependency. If you expose variable functions unnecessary, it invites other developers to use and depends of those otherwise private pieces. While that doesn't break your program today, it creates a refactoring hazard in the future, because now you cannot as easily refactor that variable or function without potentially breaking other part of the software that you don't control. For example, if your code relies on an array of number and you later decide it is better to use some other data structure instead of an array, you now must take on the liability of adjusting other affected part of the software. Paul, as applied to variable function scoping, essentially says default to exposure the bare minimum necessary variables and functions in the particular scope, keeping everything else as private as possible. Declare a variable in a small and deeply nested of scope as possible, rather than placing everything in the global or even outer function scope. If you design your software according, you have much greater chance of avoiding or at least minimizing these three hazards. So name a collision, the unexpected behavior that can happen when you expose private method, and some developers might use it in not according to the intent they were defined, and it will create now a nightmare by exposing its unintended dependencies here. So consider this, right? In this particular code, what is checking is the difference here. Hey, what is the difference between this? In this diff function, we want to ensure that g is greater than or equal to x. Okay? So that when we subtract g minus x, the result is 0 or larger. If x is initially larger, the result will be negative. So we swap the x and g using the temporal value to keep the result positive. In this simple example, it doesn't seem to matter whether temporal is inside the if blocks or whether it belongs at a functional level. It certainly shouldn't be a global variable. However, following the pole principle, temporal should be as hidden in scope as possible. So we block the scope temporal using let to the if block. Again, this is because they're using this, right? That's why I prefer to go with being explicit rather than implicit. I will agree that most developers are in that case, especially when what this function does. What is the meaning of this functionality here? All right. So yeah, that makes a lot of sense. So hiding in plain function scope. It should be clear why it is important to hide our variables and function declaration in the lowest, most deeply nested scope possible. But how do we do so? We have already seen the let and cons keywords, which are block scope declarators, and we'll come back to them in a more detail shortly. But first, what about hiding vars or function declaration in a scope? That can easily be done by wrapping a function scope around a declaration. And let's consider an example where function scoping can be useful. The mathematical operation factorial, notated as 6 factorial, is the multiplication of a given integer against all successively lower integer down to 1. Is a good way of how you can express this, right? Actually, you can stop at 2 since multiplying 1 does nothing. In other words, 6 factorial is the same as 6 times 5 factorial, which is the same as 6 times 5 times 4 factorial, and so on and so forth, right? Because of the nature of the math involved, once any given integer factorial like this has been calculated, and we shouldn't need to do that work again, as it is always be the answer. So if you natively calculate factorial 6, then later once you calculate factorial 7, you might unnecessarily recalculate the factorial of all the integer from 2 up to 6. Yes. If you're willing to trade memory for speed, you can solve that wasted computation by catching each integer factorial as it is calculated. So you hold that into a catch where you say, hey, if this is less than 2, you're going to return always 1, given the nature of this observable behavior of this factorial. and then you're gonna check it that, hey, if this number that we're receiving is in catch, all right. If not in catch, let me actually is now compute that. In other words, calculate that, which is calling the factorial here with now a negative value until it reaches to the base condition, which is the if minus 2, all right. And then I'm going to return now is 1. So if this is 2, I'm going to return is 1, right? So in this case, if I pass now 2, is this. If I pass is 1, is this. If I pass is 0, is this. All right. But if it's not, then it wants to now take a look at the catch. If that doesn't exist, let me now compute that. And here, what it's doing is this catch is being now holding it as reference. You are creating now a closure here with the catch here. So you are closing over the catch in the factorial function. So here when you call, for example, with 4, right? Let's say you call now with 4, and this is less than 2. No. Do we have then? No. So let me actually calculate that, which is 4 times the factorial of calling that function result. And that is, well, 4 minus 1. 4 minus 1. And then calling again, and then say 3 minus 1. And then passing is in 2 as it is. I would like to have at least is how you can now a description here, you know, how you can now is have a description here, because what happened here please create a visualization of the recursion here. I think you are, yeah, you're gonna produce is coherent results. Yeah, you're about to produce coherent results. Yeah, yeah, yeah. Exactly. Base case is this. on the call stack. 5 is not in the catch, need to calculate. 4 is not in the catch, need to calculate. 3 is not in the catch, 2 is not in the catch. When calling 1, it's a 1 is less than 2, yes, return 1. So now this will give you now the result, is to say, hey, this is 1. And now it is result is catch here. And now it is result not only is catch, but you know what factorial of 1 it is, and that is 1. And factorial 1 times that, it gives you now 2, and that will be stored into that. And then factorial is 3. We have storing all computed factorials in catch, so that across multiple calls to factorials, and the previous computations remains, but the catch variable is pretty obvious and private detail of how factorials works, not something that should be exposed in an outer scope, especially not the global scope. Exactly. Factorial here is a recursive call to itself, is a made from inside, but that's just for brevity of code sakes. A non-recursive implementation will yield the same scoping analysis with respect to catch. However, fixing this overexposure issue is not as simple as hiding the catch variables inside of factorial. As it might seem, we need catch to survive multiple calls. It must be located in a scope outside of that function. So what can we do is to wrap that into a function for that. So anytime that we call this, we keep that reference to this. Define another middle scope, for example, between the outer global scope and the inside of factorial for catch. An outer global scope. So function hide the catch like this, where you define is now a variable that is going to hold a reference to that, and return the factorial as a function reference. And anytime that you call this, you're going to now get the catch resolved as it is. So now the memory is being allocated in this scope. The hide the catch function serves no other purpose than to create a scope for catch to persist in across multiple calls to the factorial. So hey, create this catch to persist across multiple factorial calls. Reference as a value from hide the catch and store it in an outer scope variable, also named factorial. Now as we call factorial multiple times, it persists catch states hidden yet accessible only to factorials. So what we do is just to wrap this variables and expose only on function calls. So this private data, so this private data that anytime that we call this function, we're going to expose that. So here we prevent to somebody access to the catch, whether it's a good or ill intent developer. Then we return the function reference as a value from hide catch and store it in an outer scope variable, also known factorial. Now, as we call factorial multiple times, it is persistent catch stays hidden, just accessible only to factorial. Okay, but it's going to be tedious to define a name a hide the catch. Function scope each time such each time such a need for function for variable and function hiding occurs, especially since we're likely to want to avoid a name collision with these functions by giving each occurring a unique name. Mm. The illustrated technique uh, the illustrated technique catching a function computed output to optimize performance when repeated calls of the same inputs are expected is quite common in functional programming. Well, canonically referred to as memoization. This catching relies on closures, exactly, chapter 7. And also, there are memory use concern addressed in a word about memory in Appendix B. Functional programming libraries will use, provide, and optimize a vetted utility for memorization of function, which will take the place of hide the catch. Here, memorization is beyond the scope, pun intended, of our discussion, but see my functional light JavaScript books for more information. Do you have this functional light JavaScript book here? You got it? 3 years ago. mm-hmm. 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 It is no secret that I'm a functional programming nut. I evangelize functional ideas and a language where I can try to read the latest academic papers, study abstract algebra in my spare time. That works. Even in JavaScript, I refuse to write an impure statement, which is what leads to writing Professor Frisbee's mostly adequate guide to functional programming. Yep, full on dogmatic zealots. I was not always this way. I was once obsessed with objects. I love modeling the real world. I was the inventor of synthetic automatons, tinkering through the night with masterful precision. The creator of sentient puppets, fingers dancing on the keyboard to give them life, a real Gepetto. Yet after 5 solid years of writing object-oriented code, I was never quite satisfied with the outcome. It just never worked out well for me. I felt like a lousy programmer. I even lost faith that a simple, flexible codebase of decent scale was possible. I figured I had tried something different, functional programming. I began to dabble with functional idea in my everyday codebase, and much of my to my coworker dismayed, hasn't the slightly clue what I was doing. The code I wrote in those days was awful, atrocious, digital segue. The reason was a lack of clear vision or goal on what I was even trying to accomplish. My Jiminy coding cricket, if you like, was not there to guide me. It took me a long time and a lot of garbage programs to figuring out how FP. Now, after all the mess exploration, I feel that pure functional programming has delivered on its promise. Readability programs do exist. Reuse does exist. I no longer invent, but rather discover my model. I become a rogue detective uncovering a vast conspiracy core board pine full of mathematical evidence. a digital age goes to logging the characteristic of this bizarre land in the name of science. It is not perfect and I still have a lot to learn, but I have never been more satisfied in my work and pleased with the outcomes. Had this book existed when I was starting out, okay, had this book existed when I was starting out, my transition into the word functional programming would have been much easier and less destructive. This book is twofold, right and left. It will not only teach you how to use various constructs from FP effectively in your daily code, but more importantly, provide you with an aim, guiding principle that will keep you on track. You will learn functional light, a paradigm that Kyle has pioneered to enable declarative functional programming while providing balance and interoperability with the rest of the JavaScript world. You will understand the fundamental which pure FP is built upon without having to subscribe to the paradigm and it is entirely. You will gain the skills to practice and explore FP without having to rewrite existing code for it work well together. You can take a step forward in your software career without backtracking and wandering aimlessly as I did years ago. Coworkers and colleagues rejoice. Kyle is a great teacher, known for his relentless pursuit on the whole picture, leaving no nook or cranny unexplored. Yet he maintains an empathy for the learner plight. His style has resonated with the industry, leveling us all as a whole. His work has a solid place in JavaScript history and most people bookmark bar. You are in good hands. Functional programming has many different definitions. At least programmer definition is vastly different from a Haskell perspective. Ocon's functional FP bears little resemblance to the paradigm seen in Erlang. You will even find several competing definitions in JavaScript. Yet there is a tie that binds some blurry noted when a C definition, much like obscenity. Indeed, some do find FP obscene, and this book certainly captured it. The end result might not be considered idiomatic in certain circles, but the knowledge acquired here directly applies to any flavor of functional programming. This book is a terrific place to begin your FP journey, and take it away, Kyle. Mm-hmm. And the preface. Oh, okay. Really? What about now? Oh, that was weird. A monad is just a monoid in the category of and the functor. Mm-hmm. Okay, Douglas Crackford.
Greetings, programmers. So tonight's going to be a little different for me. I'm going to be showing you some code. I usually don't like talks with a lot of code in them. I find them really boring and tedious, and this should be no exception. But it's part of the story, and I think it's actually going to explain some stuff. So tonight I'm talking about monads. Monads is something that was popularized by the Haskell community and has started to infiltrate its way into other language communities, including ours. And it's a really interesting thing, a really powerful thing, but it seems impossible to understand because in addition to its being good and useful, it's also cursed. And the curse of the monad is that once you get the epiphany, once you understand, oh, that's what it is, you lose the ability to explain it to anybody else. There is tons of evidence for this.
Even for you, like
go to Yahoo and Google for monad or monad tutorial or monad burrito or monad anything, and you'll find this stuff and someone will go, oh, okay, I understand it now. And you read what they write, and it won't make any sense at all. So that's the curse of the monad. So
anyway, but this is okay. This is something that goes beyond of this. All right. I do think this is something that we might read later on. This is not part of today's video. That's for sure. um, mm-hmm. Mm. A good to present fundamental FP concept from the ground up, with fewer special or non-intuitive terms that most approach to FP. We'll try to take a practical approach to each principle rather than a purely arithmetic academic angle. There will be terms, no doubt. There will be terms, no doubt. But we'll be careful and deliberate about introducing them and explaining why they are important. Sadly, I am not a card carrying member of the FP Cool Kids Club. I have never been formally taught anything about FP, and I thought I have a CS academic background and I'm decent at math. Mathematical notation is not how my brain understands programming. Mathematical notation is not how my brain understands programming. I have never written a line of a scheme, closure, or Haskell. I am not an old school Lisp. I have attended countless conference talks about FP, each one with the desperate clinging hope that finally this time will be the time I understand what this whole functional programming mysticism is all about. Again, this is something that go beyond today's video, okay? Uh, but it's important at least to I just bookmark that. Rather than defining a new and unique name function each time one of those scope only for the purpose of hiding a variable situation occur, a perhaps better solution is to use a function expression for this. So when you have this function expression, what you're doing is to let me invoke this function, all right? Held that value here as a factorial, and because this function that I'm passing here is a reference, okay, so I am passing here this function reference. Holy hell. I am passing here now this function reference as an argument, okay? And then I want to call it. So for example, if you here, right? If you define this exactly, because now you have is a function reference. Wait, this is still using a function to create a scope from hide and catch. And in this case, the function is still named hide and catch. So how does that solve anything? Recall the function named scope in chapter 3, what happens to the name identifier from a function expression is now called as a factorial, right? Since hide and catch is defined as a function expression instead of the function's declaration, its name is in the own scope. Exactly. Its name is in its own scope, essentially the same scope as catch, rather than in the outer global scope. That means that we can name every single occurrence of such a function expression the exact same name and never have any collisions. More appropriately, we can name each occurrence semantically based on whatever it is we're trying to hide, and not worry that whatever name we choose is going to collide with any other function expression scope in the program. In fact, we could just leave off the name entirely, thus defining an anonymous function expression. Exactly. Thus defining an anonymous function expression instead. But Appendix A will discuss the importance of names even for such scope only functions, especially if you want to have access to this particular reference. Invoking function expressions immediately. There's another important bit in the previous factorial recursive program that's easy to miss. The line at the end of the function expression that contain is this. Because here what you're saying is like, hey, I'm going to pass. It's like I'm going to execute this. I'm not. I don't know what you're doing. To be honest, I don't know. I'm assuming that. No, I don't know. I don't know. I don't know. I don't know. There is an important bit in this. So what I do know is that anytime that you now define is parentheses, you are telling to evaluate something. Okay? It's like, hey, I do want to evaluate this, aka return now this factorial, all right? And then the second argument here is to now pass some arguments, if that needs so, or initial arguments. So for example, if you do something like that means when okay, is this invoking function expression immediately. There is another important bit in the previous factorial recursive program that is easy to miss. The line at the end of the function expression that contains this. Notice that we surround the entire function expression in a set of parentheses, and then on the end we add that second parenthesis sets. That's actually calling the function expression. We just define. Moreover, in this case, the first set of function around the function expression is not strictly necessary. More on that in a moment. But we use them for readability's sake anyway. So in other words, we are defining a function expression that's then immediately invoked. And this common pattern has a very creative name. Immediately invoke function expression. So in other words, you are defining this function. Holy hell. You are defining this function here, but then you can call it here. And now receive something. Right? And say, hey, hello, input, right? And then you say is this world function statement require a function name. That's interesting. They say hello. So you cannot invoke that? That's interesting because now here is an early error. It's an early error. It say, hey, it needs this function statement. Function statement requires a function name, and then statement is something that it calls to an action. But if we do something like this, it will execute that. So if we, for example, do something like this, and then we say greeting, it will execute that with the word, with the name word. And then when we pass now greeting here, we say there. Unlike early with hide the catch, whether the outer surrounding we note it as being an optional stylistic choice. For the standalone immediately invoked function expression, they are required. They distinguish the function as expression and not as a statement. They distinguish is the function not as a statement, not as a declaration, but as a statement here. A call to action. For consistency, however, always surround an immediately invoked function with parentheses. For a standalone immediately function expression, they require the distinction of the function as an expression, not an statement. Technically, the surroundings parentheses aren't the only syntactic way to ensure the function is an immediately invoked function expression. It's treated by the JavaScript parser as a function expression. So we look at some other options in Appendix A. In Appendix A. Oh, exactly. In Appendix is like other way of how you can now indicate that this is not a function declaration, but rather a function expression, a function statement here. I actually kind of like using void unity operator when defining a standalone immediately invoked function expression. The benefit of void is clearly communicate at the beginning of the function that immediately invoked function expression won't be returning any value. However, you define your IV, show them some love by giving the name. Wait, what? There you go. Invoking function expressions immediately. And then function boundaries. Be aware that using the immediately invoked function expression to define a scope can have some unintended consequence. Depending on the code around it, because of an immediately function expression is a full function. The function boundaries alter the behavior of certain statement and constructs. For example, a return statement in some piece of code will change its meaning if an immediately invoked function expression is wrapped around it, because now the return will refer to the immediately invoked function expression. Non-arrow function immediately invoked also changes the binding of the this keyword, and more on that in object and classes book. And the statement like break and continue won't operate across an immediately invoke function expression, function boundary, to control an outer loop or block. So if the code you need to wrap, if the code you need to wrap a scope around has returned this, break, or continuing it, an immediately function expression is probably not the best approach. In that case, you might look to create a scope with a block instead of a function. So for example, this. If the code you need to wrap a scope around has a return, this, break, or continue, IIFE is not probably the best approach. Scoping with blocks. You should by this point feel fairly comfortable with the merit of creating a scope to limit identifier exposure. So far we have looked at doing this via function, immediately invoked function expression, scope. But let's now consider using let declaration with nested blocks. In general, the curly braces, pair which is a statement would act as a block but not necessarily as a scope. A block only becomes a scope if necessary to contain its block scope declaration. It has let or cons. Consider not only necessary a scope yet, and now we know the block needs to be a scope. This is now a scope true. And let I here. This is also a scope. Exactly, you are creating now a scope, block scope, another block scope, and another block scope, right? is just a block. If it's just a block, not a scope here. Makes sense, exactly. Okay, so block for iteration create its own scope, but not if statement. Really? Let me do something here. Let me see if this actually is as intended, you know? So if this is true, right? And if for some reason I define now a let variable, say greeting, and then say hello, this should be triggered now is a reference error. If this is a scope, say greeting. Exactly. So it create now a scope. In other words, it is treated now as a scope. This let here. But if you define that as a var, it will happen. In fact, it's going to now attach that to there. What the French told you do? Oh, because it's referencing is the function here. And then I now overwrite that behavior. Exactly, because I have that previously. Not all curly braces pair create blocks and thus are eligible to become scope. Object literal use curly brace pairs to delimit key value lists, but such object values are not scope. Classes use curly braces around its body definition, but this is not a block or scope. Functions use curly braces around its body, but this is not technically a block. It is a single statement for the function body. It is, however, a function scope. And the curly brace pair on switch statements around the set of case clause does not define a block scope. Other than such non-block scope, a curly brace pair can be defined a block attached to a statement like if or for, or stand alone it by itself. See the outermost, this one. Curly brace pair in the previous snippet. An explicit block of this sort, it has no declaration, it is not actual in scope and serves no operational purpose, though it can still be useful as a semantic signal. Yes, a semantic signal. Explicit standalone. Blocks have always been valid JavaScript syntax, but since they couldn't be a scope prior to ES6 let encounters, they are quite rare. However, post ES6 they're starting to catch on a little bit. In most languages that support block scoping or explicit block scope is an extremely common pattern for creating a narrow slide of the scope from one of a few variables. So following the principle of least exposure, we should embrace this pattern more widespread in JavaScript as well. Use explicit block scoping to narrow the exposure of identifier to the minimal practical. An explicit block scope can be useful even inside of another block, whether the outer block is a scope or not. Exactly. This is a block but not a scope. This is both a block and explicit scope. Here the curly brace pair inside of the if and the, so I will leave as it is, you know. So that'll be all for this video. Take care. Bye bye.